right, so I wanted to chat with you about careers in the world of geospatial technology. As Julie mentioned, I work at ESRI, Environmental Systems Research Institute. And what our whole goal is here is how can you use GIS to make you successful? Geospatial technologies or geographic information systems. So the goal here is to chat about, what do I mean by geospatial technologies? What are some career opportunities for your students? And how can you prepare them for these careers? I think we could all have a chat. I've worked with GLOBE folks for years and years and have a lot of respect for the GLOBE program. And we as an organization have worked with GLOBE for a lot of years for reasons of which I will talk about in a moment. But in brief here, we could talk about some key issues in our society, in our planet, and we'd come up with some sort of list that may or may not include a lot of these. The point is, though, that all of these issues, whether it's water quality or energy or human health, they all have a geospatial component, and therefore they can be analyzed using these geospatial technologies. For example, what Julie was talking about earlier, if you want to look at a satellite image before and after Mount St. Helens erupted, or before and after major urban development occurred in Dallas-Fort Worth, or before and after coastal erosion occurred in England, that's the kind of thing that you can look at with these geospatial tools. These technologies include geographic information systems, GPS, which I'm sure you are familiar with, global positioning systems, remote sensing, and web mapping. Now, the Department of Labor a couple years ago identified 3 hot fields for the 21st century: biotech, nanotech, and geotech. So we are firmly anchored in the geotech. Now, GIS is not just this toolbox, and it's not just a discipline or a science. It's a transformational technology. And what I mean by that is you don't want to use GIS with your students in the same old way that you use maybe paper maps. Nothing wrong with paper maps, and I worked at the U.S. Geological Survey for years and years. And I love paper maps, but theater and film out in the big world around us. So that's when motion pictures became a transformational technology, much like GIS is doing today. And some of what I'm talking about here is that for a long time, right, maps have stirred imaginations. They've inspired explorations of the unknown. For years, people have wanted to use maps to explore all kinds of places around our planet, right? So it's no different now with geospatial technologies. But now we've got a whole plethora of tools at your fingertips. For example, as I'm showing right here, this is my iPhone, and I'm using Arcgis Online on my phone. So you've got a lot of capabilities now. You're not stuck with a desktop computer or even a laptop computer. You can use this on a tablet, a phone, out in the field, or in the lab. Colorado, great place, but one of the things about Mesa County is that it has this wonderful grid, just like a lot of states with the public land survey system. So Mesa County has this funky system, F and 3/4 road, 20 and a half road. What do you mean, Joseph? 20 and a half road? It's not good enough for a 21 road. It's a little better than a 20 road, but well, no, it's actually all measured off of the Utah border, and that's so you can be 20 and a half miles east of Utah. Now, I know one of the nerdy maps I made as a teenager. I made topographic maps, street maps. Here's one of my contour maps. And all my photos actually are of people pictures as a child. They're all landscapes and cities. Anyway, I think we all get and so on. For me, the Great Auk, the last great nested right here off of the southwest coast of Iceland. So you know what Hungary toxic spill, or mapping trees or water quality on your campus or in your local neighborhood. And how can you analyze this in 2D and 3D? So as an example, students on what coastal erosion is, means looking at old historical maps in the UK versus new satellite images, so they can actually to measure the amount of coastal retreat. And what we're talking about here is really inquiry, right? We're talking about asking these questions, gathering some data, exploring that data, analyzing it, and that might lead GIS to say, where is Yemen? Where is Boulder, Colorado? Where is Julie's office, etc. We're actually using it to investigate real-world issues. So it's very much standards-based, inquiry-based. The little secret here is that it's too good for just one discipline. It's too good for just the geographers, folks. And I come from the geography discipline. Spent a lot of time with science educators over the years and at the USGS as well. And so this wonderful world of spatial technologies, because it really does help students to really look at the big picture and also to analyze, synthesize, all that good stuff at the top of Bloom's taxonomy. And even though you can make some pretty maps with a GIS, it's really about analyzing the world and its people. This is a screenshot from a book called Teachers and Machines, the very small technology. Gosh, they're in an airplane. Cool. But they've got desks on the plane. They've got a globe at the front. They're pointing at the globe, and this student has got her head down on the desk. Anyway, they're using new technologies, but they're not looking out the window. Now, one of the things that I like to identify with geotechnologies is that it encourages these three ships. Having students really analyze and write and communicate, and the artisanship part is developing real-world job skills, and the citizenship part is looking at their own community, as I say in this slide. And again, the career connections are vast. So geotechnologies is not the end goal. Yeah, they're going to gain some good skills there, but it's a means to understand plate tectonics or biomes or climate or ecoregions, biodiversity, and so on. Also, it's a nice way for you to meet your goals of getting students to be critical of the data. Well, just because it's a map, therefore it's perfect. And just because I found that map data on the internet, therefore it's perfect. Well, wait a minute. Now, also, I wanted to mention that there is this thing called the Geospatial Technology Competency Model, and you might look at that sometime because it really underpins what I'm saying, and that is that using these technologies in the classroom really tie to, are you organized? Are you ethical? Can you deal with data? Are you good with the computer? It's not just one discipline. Now, there's lots of careers in GIS that we could chat about. But really, it's everywhere the where question is asked. So a lot of times students say, oh, Joseph, I'm not interested in geography or science, so therefore I don't care about GIS. Well, wait a minute. What are you interested in? Oh, I want to go into medicine. Don't you think as an epidemiologist you want to know about the tracking of diseases, and therefore you're not going to use some paper map. You're going to use a GIS to track those diseases and how they spread and how they affect demographics differently. Now, I really like David Orr's quote here about needing people who can think broadly and can understand systems, connections, patterns. That's really what I'm getting at here, folks. And just think of the consequences if we don't teach spatial thinking through geotechnologies. That's kind of a scary thought. Now, you'll increasingly find GIS in the job description of city planners, wildlife biologists, and all these other careers. Sure, there's still a GIS analyst or a GIS manager position, but more and more it's embedded in these other careers. And here are some places to find out more, and I can send these to Julie as well. But I like to show students real job positions that are out there in the world. And here's how to get a hold of me. The tools that we're using, this thing I'm using right now is actually Arcgis Online. And in the last minute I have with you all, I want to show you, if that's all right, a lesson, and I've got some topographic maps here. And I also have some plate boundaries. So let's turn on the plate boundaries. So, okay, and I actually have,
popping up
look at the legend, different kinds of plate boundaries here. So now let's go back to this so we can turn on the last 7 days of earthquakes. So this is a real feed that's coming in from the USGS. So now I can see that certain kind of plate boundaries, like these converging plate boundaries on the western edge of South America, actually see more earthquakes than these spreading centers, right? Which is exactly what you probably teach inside your plate tectonics lesson. Now, I know a lot of you are probably from North America, so let's zoom in over there. And this is a real-time earthquake feed. So we've got this earthquake down by Trinidad, Colorado, that was on the 9th, right? So Saturday, we had an earthquake there. Fortunately, it was a quake streaming in from the USGS. Well, what about historical earthquakes? I'm going to turn that layer on. Quakes. And then if I had 30 more seconds off of, and then I could click on these earthquakes, and then I would see that. Let's take a look at volcanoes now. Okay, so here are the volcanoes. Yes, in the same way, we're going to enable the pop-up as well, and we're going to look at the volcanoes, which is right here. I'm going to go to Arcgis Online. And all I did there was I started off with plates, and I looked for the plate layer that I made, and I was able to get a couple of thumbnails and plate lines and plate, there it is. So love to chat with you more about that, how you might do this in the classroom or in the GLOBE program. Think about mapping your own GLOBE data, and that is completely easy to do within this online GIS environment, again, called Arcgis Online. Thanks. Question?
So if there are any more questions, Joseph, can you share your email address again, or do you want me to send them you do the questions separately? I know there's more that come in.
Yep, I'm seeing those.
Yes, we can see it. Okay, so people who we don't time to answer their questions tonight, please email Joseph or email me, and I'll get him your questions. Because he's been more than willing to help us out with these things.
Julie, do you want me to answer a few of these, or do you want to move on to your next thing and just have me respond to these and then send
Okay, so we're going to move on to the teacher presenters. Thank you again, Joseph. I really appreciate taking time to do this.
Okay.
And
you want me to do it with the audio or type this in, as I don't want to impinge on other people's presentations. Okay. Okay, first the song. No, just kidding. Yes, Michelle's wondering, how do you map your own GLOBE data inside ArcGIS? I would do it in ArcGIS Online. If you have a spreadsheet, save it out, for example. One way to do it is to save it as a CSV, comma separated value, and then you can go into ArcGIS Online and add the data, and I'll just demonstrate that really fast here. So I'm going to go to, let's say we're going to zoom in here. I'm going to change the base map to imagery. And then, okay, so I've got some data here. Now I'm going to add data, and I'm going to add layer from file. So if you've got a CSV, you can add it right here. So I'm going to choose my file, and I've got a,
to Decatur here,
for example, a file that I've saved on my computer. So this would be just exactly what you would do. And I've got one here, and I'm going to import that layer, and here is a data set. I'm going to change
in my
the
area
symbology
was that
so
there was lots of
that
vandalism to the area we were studying. We were studying the outdoor lab, and there's lots of trash and different
change
things.
symbols, and I'm
we
going to map it this time on How About Elevation. This was a track that I
clean this up.
took.
That started the whole
And
process,
okay, so
really
I mean, it's nothing more complicated than that. So you, instead of your track points from your field work with the students, this could be dots of your pH and streams, or your your soil chemistry, or your tree height and tree species, that sort of thing. So that's one thing I wanted to say, is that it's quite easy to bring in globe data.
And then we have our outdoor
Kim's
lab.
asking, where do you get the earthquake and volcano layers? They're already on ArcGIS Online, and those are just feeds from places like the Pacific Disaster Center, USGS, and others. So the nice thing is that all these agencies that are, again, producing data, they put their data up there inside this cloud GIS environment, and you've got full access to a boatload of data.
We also have
okay, now Twyla's wondering about this expense. No, nothing I've done actually costs any money. This is right running in a web browser, and you're freely available to go out and play in that sandbox. Also, you can save maps. That map that I pulled up, that I looked at my own map, I saved it, right? So that way I can come into the classroom, in a week's time, and then go ahead and open it up and have the students open it up.
As we like to call them.
Okay, so
I am working with my high ability class, and then Marianne is working with the 8th graders.
Yeah, there's definitely a lot of lessons. Peter's asking about, what kind of lessons tie into this. Some teachers, they tell me, just send me the map and the data, and I can create my own lesson. Other people want short lessons, other people want longer lessons. So there are definitely lessons out there in that website that I had associated with my intro slide. And
some of the other kids
there are no shortage
actually were very excited
of
about
those
cleaning
things. So,
it up, and they went out with us, and we had a competition to see who could collect the most trash. So we ended up
happy to do a whole webinar too on ArcGIS Online. I've talked to Julie about it too.
Yes,
so
it was very
she seems
interesting.
Open to the idea. So it's
okay,
guys,
8B is my area, and this is,
I know that 10 minutes with this is not enough.
area, and it's literally an enclosed courtyard area, and the pond itself is self-contained. There's no in keep the